Hello, hello, hello. Welcome to another Behind the Research stream. It's me, Seb,
I'm me, Matt.
and today we'll be having an interview with Ben Walker. Hello, Ben. Oh, how are you doing? Oh, I'm doing very well. Very nice.
Good.
Yeah. And end of a good week. Been
Yeah.
making some progress with things. Doing some coding.
Zoom audio is not working.
The Zoom audio is not
Is that
working.
like, oh.
In what regard?
We can't hear Ben.
We're back now.
Hello.
Hello.
Hi.
Take two. Hi.
So.
Can you hear me
We
now?
can be heard. Sends us on this morning.
It'll be fine. It'll be fine.
Hello, welcome. It's nice to have you, Ben, here after this very smooth transition, smooth beginning of a very professional stream.
Very nice to be here. Thanks very much.
Perfect.
All right.
All
So
right.
let's get cracking. What sort of what exactly?
It's all gone wrong again.
It's all gone wrong again. Is it
Fine.
okay now?
Yeah,
Is
it's
it okay?
fine. Okay.
Lots
Okay.
of bloopers. This is good. No,
All right.
authentic experience.
Take number 5.
So Ben, what exactly is your position? Where are you
So
based?
I'm a lecturer in applied maths in Bath, although I've actually not given a single lecture whilst I've been in Bath, so I'm not sure that title actually makes sense. Because I'm also a research fellow funded by a funder with a very long name, which we can abbreviate to 1851 because it's much easier to say. So I spend most of my time just doing research, really, as well as a few master's student-y type things.
Oh, nice. So you say that as a lecturer, you haven't done any lecturing? Like, how does that work out? Like, why is that the case?
So it's precisely because I came on some postdoc level funding that basically is supposed to buy out all of my teaching time. So in principle, I have all the same responsibilities of a lecturer, like with my time split into chunks, some for research, some for teaching, and then that teaching bit is paid for by my research fellowship, which means I get to spend the whole time doing research. And in principle, that money goes to fund someone else to do the teaching, I think is the general gist. I'm not sure how it actually works in practice, but at least at the very high level, I think that's how it works.
Okay.
Which is a shame because I really like teaching.
Yeah.
Yeah, it's
It's
been a shame to miss out on
that
it.
in the future, I guess.
Do you do much teaching?
I do a little bit of tutoring. Did a little bit.
Yeah. I've done like a fair amount of tutoring, never like lecture kind of level of thing, but I always like really enjoy it. And just like, getting like the students engaged and what have you, and like excited.
Yeah, it's really nice. I spent a lot of time teaching during the pandemic, which was a really strange time because I had a position at a previous university and had about a term's worth of doing really nice face-to-face teaching, and then it just immediately, well, obviously as everything did, switched to online teaching. That was quite a fun challenge. Very difficult, but it was interesting adapting to new types of teaching.
Yeah. So how did you like adapt? Like what sort of things did you do?
Well, I adapted terribly, I think, to begin with. It was my poor students. It was probably quite rubbish. I think the hardest bit, which maybe is still the hardest bit in any online teaching, is just actually getting people to interact. That was really, really difficult. So fortunately, at the time, I was doing really small group teaching. So it was like 1 or 2 people that I was teaching at a time. So there it was much easier to have just more of a chat, really, about work. So that didn't have to change very much. The lack of being able to see somebody's work or write on pen and paper in front of someone was a hassle that we didn't get over. Some people had tablets and that was great, and some people didn't have tablets because they're expensive, and why would you have a tablet? So that was a real barrier that I don't think we completely overcame in the end. We managed to get some funding actually to give people loads of graphics tablets, which was a 50-50 solution, but very cheap, very bad ones that didn't really work, but it was closer.
Okay. No, it's very interesting. Very interesting. Yeah,
it was very strange times back then. Very strange. I mean, at the time I was going through my undergrad, it was halfway through. It was very strange world adapting to that.
Yeah, very strange time to do an undergrad as well. So I was partway through my PhD, so already doing what I think many people would agree can be quite an isolating part of academia, doing your PhD, to then have to do it from the comfort of my own home, locked inside, was a bit of a shift, really.
Yeah. I do find that like even now, like I'm it's just like I've got too much of a strong like work-life divide. Like when I like go home, I don't do like any work at all. And so on some days, I even to this day, I keep myself like, oh, today will be different. I can, work from home, do some like, coding, like reading some papers, and I just it's largely unproductive. And I keep on telling myself like, oh, maybe this time it will be different. But
every single time.
Well, I think it's a great idea to have that work-life separation with it. So it's something I really struggled with. Maybe this is due to the pandemic. Maybe it's just because of I find it really hard to switch off anyway. There was a part of my PhD when I convinced myself that I had to work every hour of every day and didn't take weekends off, and this was really bad. This was not a good idea. I think I lasted a couple of months and then burnt out a bit. Whereas now I try to be really strict with weekends and evenings as much as is possible. It's nice to not do some work sometimes.
Yeah, as it happens, shockingly.
As it happens. There are other things.
Yeah, I think like, the biggest thing for me is that I don't have like a dedicated office at home. I'm just like in my bedroom where I just do like my gaming and like watching like YouTube videos anyway. So when I get in there, like, okay, time to like, just mindlessly watch hour-long YouTube videos. So I think that's probably like I reckon if I had like a dedicated office, maybe things would be different.
Then you need to have the space.
Yeah.
I'm in my living room, so
nice, cozy.
My blurry living room, I expect.
Yeah.
Should we go back to the very start?
Yes.
Like a background?
Yeah, sure.
Maybe. Yeah. All right. Okay. Let's have a good question now. So let's go back to the very, very start then. So when was for you maths like the future? When did you think you wanted to keep doing maths in the very start?
Oh, I feel like I'm the absolute cliche with this, and that there was never really an alternative. Actually, that maybe that's not fair. So I always really enjoyed maths, always at school, but I also equally enjoyed basically all of the sciences. I enjoyed quite a lot of school, but especially all the sciences, and I could happily, I think, have branched into any of like biology, chemistry, physics, or maths when I was choosing to go to university. I did all of them for A level and was really glad I did that. But then it was hard to choose. Maths just seemed the most natural. It was the subject I perhaps resonated with a little bit more, but there was never it wasn't I hated all the other things, or I particularly loved maths way more than anything else. It just kind of ended up the way it did.
Okay.
How about the two of you?
That's really interesting. Oh, I'm going to go with the cliche one, I think.
What?
That's the only thing I was good at. And that's being tested every day now. What yourself then?
I mean, it definitely was like my strongest subject. Like I was okay at physics. I didn't do like chemistry. I did want to do art for a while. I wanted to be like a concept artist. And so I did like art, I did art GCSE, and I think I did it. Yeah, and I did it for AS level as well. But then I dropped it for my A2s. Actually, did I do it for AS? I'm not sure. I don't know. I did something for art, and I had a lovely time, but I wasn't super good at it, so I dropped it to do more STEM subjects. Yeah.
I was particularly terrible at art. I have no talent for drawing diagrams, as anyone who's been in one of my tutorials will attest to.
That's quite a relatable problem. I wouldn't worry too much.
Yeah.
So you said at your A level you did all 3 sciences and maths on top of that?
Yeah, it was. I didn't really have a concept of 3 periods, which lots of my friends did. I did the 3 sort of hard sciences, if you would, and then maths and further maths. So it was a busy time.
So 5 A levels.
Good fun though. Yeah.
Yikes.
God, I only did 3.
Yeah, likewise.
That seems very sensible. Yeah. This is not a recommendation or endorsement for doing 5.
Okay.
No, absolutely not. So from here onwards, you decided university was the right choice for you with maths. Could you tell us maybe a bit about your uni experience?
Yeah, so it was terrifying, I think. So I went to, well, I'm from Sheffield originally, so somewhere in South Yorkshire. That's we weren't especially affluent, but we wouldn't have said we weren't affluent. Somewhere in between. Certainly, I'd worn a suit twice, and that was for 2 special occasions at school rather than that. So wearing a shirt was a little bit odd. And then I went to Oxford for my undergrad and got much more comfortable wearing shirts under duress, essentially, needing to, dress up in subfusk, they call it. I don't know if either of you have ever been or seen this. It's a bit intense. So for all exams, you'd be in shirt, white bow tie, a suit.
Really?
And had to carry a silly hat around as well. Sorry, very sensible, serious hat around in the middle of summer as well. So this was that was quite a culture shock. Quite a culture shock for me. It was the environment that could have been very isolating, but fortunately the group of friends that I had in the college that I was at was essentially full of people who I decided were like me. So there was none of the sort of the usual Oxford stereotypes, other than that you might see, and people would dress funny occasionally. But it was actually a really nice experience. It was scary at first, but it was a really welcoming environment that I was at. Maybe I think the different colleges matter, but my group of friends were really great, so that was really nice.
Oh, that's good. That's good to hear. Good. Yeah,
that is very.
It was good fun. Yeah, yeah. Undergrad was particularly fun. It was very nice.
Yes,
doing lots of different types of maths.
Yeah, of course. So, like, at what point did you decide that, maybe I want to, take this sort of like studying, like research sort of thing, like beyond like a university?
So I definitely had no idea what research was. I did a math bio course in my 3rd year, and I really enjoyed it, and I wanted to do some more. So I somehow plucked up the sort of mad bravery to ask the lecturer if there was an opportunity to do more things, which I wouldn't say I'm a particularly confident person, especially doing this sort of thing. But I'm really glad I managed to do it. This lecturer was super friendly and really nice as well. He's Philip Maney in Oxford. If you ever get a chance to meet him, he's fantastic. But anyway, so I did this, and after lots of my schedule not working with anyone else's schedule, I ended up doing a 4th year project, which is now compulsory, I think, in most places. So that was my first taste of research. And it was kind of fun. I really enjoyed it. It was nice doing things sort of at my own pace, or a bit more explorative, rather than having to do problem sheet questions, which were fun in their own right, but a different flavor. And then my heart was set on doing a PhD, and never really changed my mind from there. I scarily applied to a fair few places, and was lucky enough to get in, which was nice.
Ah, nice. So, like, what sort of area was like your final year, like your 4th year project in? Like, what was it about?
So it ended up being in really lots of the things that I still do, however many years later. So it was on small things that swim. So my research typically, or a big part of it, is on how microorganisms move about. So I'm thinking things on the scale of bacteria or sperm or algae, or all these sorts of things, like proper micro scale. And it turns out there's loads of cool fluid dynamics associated with these problems. At those small scales, you're in a Stokes flow or a low Reynolds number environment. And it turns out that the fluid flow equations lead to, they have really lovely properties, basically, that mean you can actually do things analytically, do things with pen and paper, and actually explore what's going on, at least in simple cases. So that was what my project started in. I'm fairly sure that everything I did in that project is wrong, but I at least got the flavor of what was going on. And that really span out into the PhD project, and I spent a lot of time working around that sort of thing. So I must have liked it enough to have wanted to carry on, and still do it, I suppose.
Yeah, and where do you do your PhD?
So I stayed in the same place. So I stayed in Oxford for another 4 or so years. I think I ended up living in Oxford for maybe 9 years, which is a quite a substantial part of my life at this point. But it was a nice environment. It was really different to undergrad, actually. The PhD or DPhil experience was really different. you were so as an undergrad, basically all my friends were from college, doing a variety of subjects. Whereas that completely pivoted at PhD level when it was you'd more spend time with the people in your research group, quite broadly interpreted research group. So just people that did math bio usually, but it was still really nice. It was really fun. I did have an office that was basically a greenhouse, though. That was a bit sad. This is not a good thing. It had a completely beautiful view, lovely glass windows, but also when the sun came out, it would reach mid-30 degrees Celsius, which is slightly too warm to work in comfortably.
Yeah, I can agree with this.
So I had I had an office, but I had an oven basically.
Yeah. So do like the colleges like matter at all at the PhD level? Like how much of a role do they play?
A tiny role, I think, or at least for me, it was a much smaller role. So I ended up staying at the same college at Wadham because I'd been doing some rowing in the last couple of years. I took the plunge into even more stereotypes by doing that. So I was still doing things with the boat club, so it made sense to carry on doing that. And there was no reason to swap. I mean, I still know some of the people I met at Wadham as a DPhil student, but it was definitely a lot less involved. I didn't live in college or really do anything associated with it other than popping in for some social occasions. Whereas in undergrad, I lived on the main site for a year, for instance. Maybe 2 years. 2 years, in fact. Yeah.
Ooh. Yeah, but like the research groups, they're not like restricted to college and they're more just
no, absolutely
university-wide.
Nothing. Yeah, exactly. The college is essentially irrelevant as far as your studies go in that sense. Occasionally some colleges will have some opportunities for teaching basically, but that doesn't really matter which college you were at for this sort of thing. You could apply.
I see.
Regardless.
Okay. Yeah, nice. And did you do your PhD like thesis with like the same like supervisor that you did your final year?
I did, yeah. So me and my supervisor, Eamon Gaffney, we got on really well, or at least I like to think we did. Hope he doesn't contradict me. Yeah, we got on really well, and that turned into the DPhil project. And he was my only supervisor actually for that course. And I think now you have to have a pair, but it was just Eamon and I that went through. And we still work together pretty frequently as well. So I would say maybe half the things I've ever done have been in some way collaborating with Eamon, which is great. It's such a nice thing to work with.
Oh, nice.
I realized I was quite lucky. Lots of people don't necessarily get on quite so well with their supervisors in either in a personal way or in a worky way. But it seemed to work really well with Eamon, so I'm very, very lucky.
That is very lucky.
Oh, that's very good to hear. Very good to hear. Yeah. And was it in like the same area then? I presume. Like, was it like a direct continuation or completely
it
different?
Was a direct continuation. So it was. I'm not necessarily sure that I'd offer that as advice. I'm not sure if I'd say you should always carry on your master's level project for your PhD. I think there's definitely something to be said for branching out. So whilst my thesis was focused on the same thing I did in my fourth year, I ended up working with, doing some pieces of work with other staff members in the department during my PhD, which was really fun because that was on something completely different, and that was a really, really nice experience.
Ooh, nice. And like, how do you like decide that like, okay, no, for my PhD, this is the thing that I want to do. Like, I like this topic, like enough to do this. Like, how do you? Like, I guess like the final year project helps you get a lot of experience in it, so you're like comfortable with it.
Yeah, that's true. It's so I think there's no good answer to this question, or if there is, I don't know what it is. Is that it just has to be a topic that you think is interesting enough. That's really vague. That's basically what you said, but it's it's something that you would be happy to dedicate months and months and months to thinking about problems. And what was really nice about this particular area is that as soon as this is probably true for most areas, but as soon as you answer one question, there are tens and tens and tens of different problems. But in microswimming, they're all to do with different applications. So you can go vying towards medicine in the distant future and look at fertility, for instance, and study sperm in lots of detail, which lots of people do. Or you can go an entirely different route and study bacteria, which are fundamentally very different, and the sorts of questions that you might ask are really different. So I really liked the diversity. There were so many genuinely different branches to go down, and it was nice to have that freedom all the way through.
Nice.
Yeah, that's really interesting, isn't it, actually? Because from like a bar's point of view, there's we got the Samba program where you have a year at the very start to kind of explore all these different areas that you fancy. Obviously, going straight into it's a very different experience. It's quite interesting thoughts on that. Yeah.
Yeah, I think the doctoral training centres are a really good idea. I think I would have really enjoyed one. There was one I applied to in Oxford, I can't remember what it was now, that would have done something very similar. And I think they're a great idea, especially if you don't have a particular project in mind. I mean, you learn some new skills, you get to meet a cohort of people, which I think is, not something to turn down, especially when you're about to start a PhD. But yeah, getting to meet lots of supervisors potentially and do lots of different projects is also probably quite fun as well. I like to think I do research because it's fun and I enjoy it. I think that is definitely true.
Yeah, I definitely find that as Samba, like the cohort structure was definitely like one of the main appeal points to me, to have that sort of like inbuilt kind of like support network already there.
Yeah, absolutely. Especially like you say, Ben, like PhD, it's a lonely experience. It can be very lonely. So to have those people around you is fantastic experience. But that's really good. So you obviously like research. So you decided then after, I think, to do a postdoc.
Yeah, so I had so it was I had just over a year to go, I think, until my funding was going to run out for my PhD. So everything was timed around having no gaps, basically, because I quite like being paid every month. It's quite nice to have this. So I applied for a whole host of things. So I had a short postdoc out in Oxford for 6 months. So this was an EPSRC doctoral prize scheme, which doesn't sound anywhere near as fancy as I think it is. So it's still very nice to have. Different universities run these differently, but they typically allocate some amount of money from the EPSRC that funds all of the PhDs, basically, and use it to extend projects as a maybe finishing stuff up or just developing an idea that you had during your PhD. So in Oxford, those were typically roughly 6 months. At UCL, I know they're like a year to 2 years, for instance, and that was a really lovely thing to have, because what I was hoping for was a fellowship. So that was one of the more lofty things I just threw the dice on lots of times, really. So during this last year of my PhD, I applied for, I think I counted in prep for this stream, it was like 11 things, 11 slightly different schemes, all of which required different applications and things, in order to get a research fellowship. So some potentially long-term funding, but also freedom, so that there wasn't going to be I could do whatever I wanted, basically, without being on someone's project already.
Okay, so is that the difference between like a postdoc and a research fellowship? Is the more like yeah,
absolutely, yeah. So I think that different schemes might say you're a fellow even though you might be more of a traditional postdoc. But if we say put things into two bins, one is a postdoc where you're funded on a grant that a supervisor has got, for instance. People call them principal investigators, like PIs, and that's typically in sciencey things. But they'll have got some money from somewhere, many different sources, and then you'll be funded on that grant. That's typically to do a particular project. So that will be anywhere from, I think they go as low as 6 months, so that's pretty low, and then longer and longer up to like 3 or potentially even 5 years, but usually to work on a specific thing. And as lots of supervisors might let you do some other things at the same time, but that's up to the particular dynamic. Whereas the difference between that and a fellowship is that in a fellowship, it's your project. So you would write the proposal typically to do a particular bit of work that you think is interesting. It's normally quite broad strokes for usually, I'm going to say usually 2 to 3 years, but they vary very significantly. And then you essentially don't have a boss on that one. You might have a formal line manager in some sense, and maybe someone to help out for advice, but you direct the research. Which is a bit terrifying, I think, actually. It was quite a scary thing for me to do, was to jump from my PhD to then do that short postdoc in Oxford, which was essentially just a continuation of my PhD, and then jump straight into 3 years of directing my own research and being able to do what I like. which has led to a lot more breadth than I perhaps imagined to begin with. It's been nice and fun, but you get freedom in some sense.
Yeah, so I'm like in a kind of getting to a similar position myself. So I'm like in my final year PhD, and I'm applying to like some postdocs. And I see like these like fellowship things. I see like, oh, please write some like research proposal. And I just don't feel like I know what's worthy of like going and researching for 2 years or something. So do you have any sort of like advice to give regarding that kind of feeling?
So I can try. I think it's quite natural. I would say I think it's really natural to not think that your research is worthy of going to do research and having funding and things to do it. I feel like most researchers go through this all the time. I think asking your colleagues or friends or people who maybe aren't your friends, just to see what they think and provide some feedback. So I was terrible at writing proposals. Maybe I still am, but I got loads of support from my supervisor, because I was still writing them during my PhD, and also from there was a team in the department that I was in that helped with this sort of thing. I imagine there's something very similar in lots of universities where they can help you write grant proposals, because these things are difficult and hard and intricate, and just getting lots of feedback is really good. As far as deciding whether your research is interesting or not, so long as you believe in it, that's usually enough. So long as if you can find some references or make a compelling argument as to why this might lead to X, Y, and Z in the future, depending on the scheme you're applying to, it will be different, of course. But so long as there's some sort of evidence train of thought, I feel like lots of things can be justified as interesting. Then you have to roll the dice, with things getting reviewed and random people's opinions. Unsolicited advice now, please forgive me, is that just so I don't forget to say it. So I said I applied for loads of things. It was like 11. And I got one. I got one that I'm currently about to finish. And I think it was the best one for me. And it was one of 2 out of 11 that I actually got. So
Whoa.
I applied to 11 things and got, I think it was 9 rejections in a row, and then 2 yeses at the end. One of them was for a much shorter thing, and then one was for this fellowship that I ended up getting. Even though it was roughly the same application material, same project idea, I was the same person, but it was a 2 in 11 chance, seemingly, in order to get that. So the advice I was given was, don't attach any self-worth to the outcome of your applications for these things, because they're not measures of you or your science. They're a measure of, did the dice roll come up in the way you want it? And sure, you can try and weight that dice roll by doing this, that, and the other to build your research portfolio, etc. But realistically, it does just come down to a dice roll. This is an annoying theme throughout academia, unfortunately. But that was useful advice given to me. So I just wanted to shoehorn it into this conversation.
Yeah, no, definitely valuable, very valuable. It's just like an inherently just very competitive sort of field to acquire funding and what have you.
Yeah. I think oh no, sorry, please. Okay.
No, I was just going to say, have you got any advice, particularly on what you can do during your PhD to give you a good chance? So you said build up your research portfolio,
which is very vague. Yeah. So something that. So I'll preface this with, I'm not an expert in getting this sort of funding. I got my 2 out of 11 that got me here. Weirdly, and this can be unhealthy as well, is that saying yes to some opportunities can be really helpful, or seeking something out that maybe is a little bit outside of your area, or if so for instance, in my department at the time, there were people wanting to do some research in something just as a group together. And I didn't have to say yes to this. I would have been fine not doing so, but doing so gave me loads more experience. I don't even think a paper ended up out of this experience. It was just working in a different environment with different people that really sort of changed or gave me a broader perspective on research. I'm not saying you should say yes to everything. This is something that people definitely feel in academia. You have to say yes to every opportunity. I definitely don't think that's true. You end up just not being able to do anything well. But just, making sure I don't like to think about things as tactical decisions, but making sure you're doing things that you think are interesting. And if you have a choice between 2 equally interesting things, picking the one that feel like is going to broaden your experience or give you something different. There's no hard and fast rule, I don't think. In some fields, you need 20,000 papers to get a postdoc. In some fields, you need one, and that's it. But you might not even need any. So it's very hard, I think, to generalize. And I think it's very easy to compare yourself against the person next to you who might be working in an entirely different field, and they've just had their third paper come out, and that's great. But that doesn't relate to your experience, and that's not really the most relevant thing in all cases. I didn't really answer your question. I definitely just said
that's great. It was
perfect answer. Yeah, I think the best answer that one can give, I suppose, given just how individually based all these different areas and people are.
Yeah.
To add to my to add to this a little bit before I forgot again, was something that was really valuable to me was just, so there were other faculty in the department other than my supervisor, shockingly enough, but just going to chat to them or ask them for some advice at some point was really beneficial. It wasn't that my supervisor was giving me bad advice. It was just different advice. It was always nice to see a different perspective. And people know different people. Lots of academia is made, whether it makes much of a difference in the end, but it feels like it's nicer when you broaden your network of people that you know. So the more you talk to people, the more you get introduced to other sorts of people. And even if that doesn't really make any tangible difference in the end, it still makes things feel nicer if you know the community a little bit better, or you have an excuse to talk to someone. That was something I found really beneficial, I suppose, broadening my perspectives, but really, getting to know a few people. And the connection might not come to anything, but if it does, that's a really nice thing.
Yeah, that's really good advice. Really good advice. I feel like the more I get stuck. So I'm in my first year. This is my first go, I guess, at everything. But even now, I feel like it's a surprisingly small community of people. So you get to know a few people, they know people, and then it's quite interesting, very interesting.
Yeah, and you always find it almost surreal when I go to a conference or someone and I meet someone and it's I've read your paper 100 times. It's almost some celebrity crush or something. It's oh my goodness, it's actually you in the flesh.
Yeah, those sorts of celebrity academia crushes are good. So, but then it's nice. So if you stay in academia, or you get to know enough people, eventually someone might come up to you and say, "I've read your paper and it was interesting." That's just, it's happened once, but it's the best feeling ever. It's definitely worth it. So
it's the dream.
I can imagine. One day.
Yeah. You can always bribe your friends to do it as well.
This is true. Okay. Shall we go on a quick little break for a few minutes, I feel?
Sure. A quick break.
Yeah, okay.
Come back.
So stay tuned and we shall return shortly.
Thanks.
Hello, welcome back. I hope you've had a nice stretch of the legs, got refilled some water or coffee or whatever beverage you're having. Yes. Alrighty. So where were we before?
Just finishing off talking about fellowship, I think.
Fellowship. And you said that as well as fellowship, you're a lecturer as well?
Yeah, so typically these things are, and this is where it gets even more complicated. So you have my fellowship was a postdoc level fellowship. So it was the same as a postdoctoral position, so no permanence or anything, fixed term for 3 years. But during that time, I also applied for permanent jobs, because for me, having a contract without an end date was really important. In principle, there are other routes to where you keep getting more and more fellowships, which are potentially longer term, for instance. But for me, I just really wanted some security. And a job popped up at the University of Bath. So I applied for it. It must have only been a few months into my fellowship, actually. So I probably had my PhD for 9 months or so when it was interviews and things. But this was very early. This was speculative. I thought it would be practice, basically, to get better at writing these sorts of applications, because it was quite a different sort of thing to have to do. And then weirdly, got offered the job, which was quite a nice weird thing to happen.
Whoa.
So that was really good. I was at UCL for my fellowship, but my funder were really nice and really flexible, as were Bath, so that I could transfer over to Bath. They'd start treating me as if I was a lecturer, which is why I get to call myself a lecturer. But then all my time would be brought out by this research fellowship, so I could keep doing the research that I was doing before, basically. So that was perfect for me in terms of the security of the permanent job, plus the time to do research that was afforded by a fellowship, a postdoc level fellowship. So that was pretty good. That was a big change for me. It was a nice weight off my mind. Fixed term contracts are probably one of the worst things about academia. They seem to be.
I agree.
They seem to persist across the world, really, having short-term contracts at the beginning. Maybe slightly worse in other countries than here, maybe slightly better, but it's it was nice for me to get off that. That was really important for me.
Yeah, and do you feel like, you know, having this fellowship already like helped you in getting a permanent position?
I think it really helped. In fact, I think I can track back. If I say success in getting jobs with some air quotes stressed heavily, I think that probably all gets traced back to a conversation I had in a lift during my PhD, where I met somebody who then recommended me for a prize, which I got, which almost certainly led to me getting my fellowship, which almost certainly led to me getting my job, basically. So, I mean, maybe I'm over-interpreting this, but those sorts of chance encounters of someone was visiting the department and I chatted to them in the lift paid off in this sense, in quite a butterfly effect kind of way, so which I could be reading into too much, but that was really helpful for me. I think, you know, it's not to say that you can't get permanent jobs just with like traditional postdoc non-fellowship positions, because that's emphatically not true. You can get loads of people don't have fellowships and get permanent jobs, but it was helpful for me getting one relatively early in my fellowship as well.
I see. And you mentioned a prize. What does this mean?
Oh, so this was so the Society for Mathematical Biology has a series of prizes, basically, and one of them was in biophysics, and it had to go to a graduate student. So I ended up being nominated for that and got it, which was very nice. It didn't come with very much money at all. It's not like getting a Fields Medal, which maybe comes with a little bit of prestige as well. But this was really, really helpful. It was, you know, these things are another roll of the dice, basically. I'm sure basically everyone that applied or was nominated is equally worthy of this sort of thing. Whether or not I was worthy is a different question. But it really helped, I think, or even just accumulating tiny little things. I'm sure it helped. There would have been many alternatives to this.
Okay, so it's a prize more of like some little sort of like tangible way of getting recognition of your work and contributions, would you say?
Yeah, exactly. But it wasn't, it's definitely not the be all and end all. It was helpful. Yeah. But I think, well, realistically, the only reason I would have got that was from I was hopefully doing some interesting research. Maybe someone was interested in it. But that was it, basically. It was a bit of good luck, really, all from a chance encounter in a lift. If that didn't happen, it wouldn't have happened. Wow. Which is why I gave this advice of take some of the opportunities, because sometimes it snowballs. I'm not saying it always will. No, I just got lucky, I think, a lot. But...
Cool.
Yeah, don't set your heart on a prize. It's
okay, noted.
It's basically a slightly big book token and some more words to write down. I'm very grateful to my funder for the prize.
Let's go without saying.
Really. So, Ben, you said the fellowship so you mentioned before, so it has a massive name.
So my funder are the Royal Commission for the Exhibition of 1851, which just rolls off the tongue very naturally. If you spend any time in London around South Kensington, you will see their logo stamped on basically every building.
Okay.
So they were, so the Great Exhibition of 1851, I might be telling you things you already know, was what the Crystal Palace was built for. The giant Crystal Palace, the big greenhouse, was made for this exhibition of sort of Brunellian engineering and all the things that made the Victorian era great. And they made some money off doing this. and invested it. And this commission basically ended up funding lots of science and engineering fellowships for I suppose the last 173 years or something. And I'm very grateful. So that was, they're really curious. They own lots of the land around Imperial College and South Kensington, and a bit of the Albert Hall as well, I think, as well. You can find their logo on the side of the Albert Hall if you're curious.
Ooh, so. That's very interesting, isn't it? Very, very interesting. Should we move on to the big project?
Yeah, sure.
Project? So over the last couple of years, I assume during your fellowship time, you've been working on visual PDE. Should we think?
Yeah. That was a very smooth segue as well. I liked it. So this is an example of saying yes to things, basically. If there happens to be an audience on Twitch, if you go to visualpde.com, PDE, then you'll be able to see what we mean. So this was a project that started off because I've been working with a colleague, Andrew Krause, who's now up in Durham, who does all sorts of cool math bio things, lots of Turing patterny stuff. So I'd done a project with him, and we were at a loss of what to do next. And I happened to have a bit of time, or at least I thought I had some time. So we were at a conference, and we got chatting about something that one of his students had started playing with over the summer, trying to get some reaction diffusion Turing pattern model to run in a web browser. Which there's a few of these that you can Google and find. And he had this idea of making it a bit more interactive, along with Adam Townsend as well, who's also up in Durham. And this sort of spiraled and got completely out of control. So I spent a couple of months trying to render a 3D cube to my web browser because I've never done anything to do with the internet in any way. So I learned some HTML and some JavaScript and some library to do WebGL. And I managed to draw a cube. In fact, my partner still knows the project as the cube because it took so long to render this thing. So we have the cube, which then became a reaction diffusion simulator that runs in your web browser, which was pretty cool. I think we tried this, so I'm going to try sharing screen just so that people don't have to follow a link. We'll see if this works. So hopefully the viewers, via some magic off screen, might be able to see this screen. Let me put my head in the corner as well. Does that look good?
So,
or not terrible?
I think it's good.
No,
it looks good.
Is it good?
Yes. I'll take 5.
It's good. Okay, we've got
amazing. It's brilliant.
We're good to go.
If you want to join in at home, just Google Visual PDE and you'll find it. So what this is let me click on this simulator button. If people don't like flashing images, by the way, this is the time to turn your brightness down or put the screen, put the stream in another tab or something. So here's a partial differential equation in the top left-hand corner. I'm trying to make this bigger so that everyone can see. Here's a PDE that's now very big on my screen. So you might look at this and have absolutely no intuition for what's going to happen. And I think that's incredibly natural because I have no intuition for what's going to happen. I've got some things are changing with time. I know this is a Laplacian, so that's like spreading out in space. And then there's all sorts of horrible nonlinear stuff with some parameters A and B going on. I don't know what's going to happen. So what Visual PDE lets you do is just explore and just play. So if I click to perturb some initial condition, I think we're seeing one of the species here. Let me just put a color bar on nice and quick so that we can see. And I click go. Then what we're looking at is a numerical solution of that PDE system, which is quite complicated. I don't know what it's going to do, but it looks like it's formed some pretty cool pattern. Now, the numerics here are not super high-flying, amazingly accurate. You'll notice this has sort of fourfold-ish symmetry that's now just bifurcated a little bit, which is definitely due to the fact we're on a square grid. So don't read too much into that. The physics doesn't say you must form square grids. It's just the way we're doing it. But what it lets you do is, this is an interactive simulation. I can perturb the state and see what happens. So even if I just wiggle my mouse around somewhat wildly, a pattern reforms. It looks different to what it did before, but it's sort of vaguely the same sort of structure. I've broken the symmetry naturally. So immediately we've learned something. This pattern seems to be fairly robust, at least qualitatively, the sorts of features. But then you can ask cool questions like, well, what if I change one of the parameters in this equation? So if I was doing this a couple of years ago before I'd made Visual PDE, I would go to MATLAB or Python, I'd write my solver that was going to do this, which would have lots of mistakes in it for a long while. I'd eventually get it working, and then I'd run a simulation, maybe make a video and look at this. And then I'd do the same thing with a different parameter and try and sweep through. But now what I do, now that I've invested hundreds of hours into Visual PDE, is you can grab this slider for this parameter and just tweak it and see what happens. And the simulation is updating live with whatever those equations are. And you can see this is where it gets a bit flashy. Something qualitatively different is happening. I've got loads of spots. There's some sort of stripes still appearing, but it looks like they might be bifurcating away. There's certainly something more dynamic going on. And as we change this parameter even more, we can see it as even more possible behaviors. This is going to blink a lot now, so I'm going to get past this quite quickly. I want to try and get one of my favorite parameter regime, which is really hard to find. Oh, and I've missed it. I've missed it completely. That's okay. Let me go to there. I think that's pretty instead. But the lesson, even though we might not have done some concrete maths for this, if we've seen that there are loads of different behaviors that this system can exhibit, just depending on the signs, or not just the signs of A and B, also their precise values. So here are some nice spiral wave type things, maybe not quite spirals. So all of this was because when we teach PDEs like this to our undergraduates, we typically will show people a picture. We might occasionally stretch to a video of this sort of thing. But I found it really difficult as an undergrad to try and gain any intuition for this sort of stuff. But making Visual PDE has at least given me a way to develop my own intuition just by messing around. It's like just being really dumb about it. You don't have to know anything about the numerics. You don't have to know any analysis to try and play around with this. So for instance, if you want to know, well, what if I add on a small bit of what someone has told me is advection? Like this is a UX term. I've made this small enough, hopefully, that it won't flash uncontrollably. Well, what's going to happen now? Well, I've played with this 100 times. I know what's going to happen. But if it's the first time you're looking at this, you might not know, right? But now to just change the system, you just type something in and see what happens. Whoa. And now you get a pattern, which is, I think it's super pretty anyway. You get an entirely different sort of pattern like that. And what happens if I change the sign of this? Quick maths test for you. What does your intuition tell you?
Yeah, we'll go to the right.
Yeah, it better go to the right. That's good. Yeah, there we go.
Ooh,
but also but that's the point, is that to maybe that's easy intuition, but for more complicated things where it's not quite so obvious, you can just plug and play and see what happens. So Visual PDE is more than just this window. We have a whole site which is filled of tens and tens of examples, all of different systems, all of which we just crafted by typing different things into that interface. So you can go and make anything you see, you can go and make from scratch. I don't just want a monologue here, even though I definitely would for hours and hours. I just put up one more horrible thing and then I'll shut up for a bit and pause for breath. You do all sorts of cool, horrible equations that are nasty and nonlinear and vicious. So I had no idea what this equation was. It's called Kuramoto-Sivashinsky, I think. It's like a model-ish of chaos for some type of chaos. Don't hold me to that.
Sure.
All sorts of pretty pictures is the important part.
So this really is like quite the playground that you can work with just to mess about with these PDEs.
Exactly, completely mess about. So I've never tried this. I wonder what happens if we change this parameter. Let's give it a slider as well. Let's just make it not too much bigger and not too much smaller. I don't know what's going to happen, so this might just disappear to nothingness. Oh, very flashy, very bad. I'm going to stop that. It's not going to stream well, is it? But certainly something very different happens. If I make it 0, it goes all unstable. I'm going to pause it because that's unnecessarily flashy. I don't know if you can see this on stream. You probably can't, maybe even not on Zoom. There's it looks like there's a little shading, like crosshatch in here, which is definitely just numerics breaking at this point. But there's all sorts, you can just mess around with stuff. That's what I really love about it, is if you don't know anything about a system, you can just mess around with it and see what's going to happen, basically. And the plus side is hopefully it looks pretty-ish. And it's sort of crazy customizable. Every single thing, like this one has a weird lighting effect on it that makes it look a little bit like plasticine-y, watery stuff.
Wow.
All sorts of stuff. All right, I'm going to shut up now for a bit. Talking.
I'm just kind of like completely mesmerized by those solutions. Just look at them for so long.
And the banner is obviously a simulation.
Oh, nice. A good touch.
This is my favorite parameter regime, where it does it like splits up into lots of little pieces.
Ooh.
It looks a little bit like it reminds me a bit of the Game of Life
Game of
or
Life.
something, where you get
Yeah,
stuff spawning. So actually, I know I just brought up the Game of Life, but something I was testing the other day is converting Visual PDE into a Game of Life solver.
Oh, really?
So if my internet can cope with loading a third web page, apparently it can't. We'll leave that in the background in case it does. But we're retrofitting Visual PDE to do like cellular automata stuff as well, because it's also pretty cool. We'll see if my browser manages to load this page, which is identical to the one that's already loaded.
No, I think it's really interesting. I think particularly with applications and teaching. So as like I said, doing tutoring, I've used this because I taught people, well, I tutored PDEs. So I've used this to kind of start building intuition behind what would happen in certain cases. I think it's
That's
really
fantastic
useful for that. Yeah, it's incredibly useful for that.
I can't believe someone's used it. That's amazing. That's made my day. Unsolicited as well. That's pretty good. Very happy about
it
that.
is. It's really useful for it. Like you say, it's very hard to kind of build these things up from the ground up, especially if you're just doing it for an image or something. It's
exactly the sort of scale of this project is, I think, one of the things that well, I'm going to say makes it good, or for some definition of good. There's no reasonable reason to make any of this sort of stuff in the way. This was all just a passion project that was done in evenings and weekends for a while, because it was fun, because I wanted to render this cube. And every single feature that lives in Visual PDE, like typesetting these custom equations, it is all just, one of us thought it would be cool, so we went away and built it. And changed everything about it. So it's not reasonable to have to spend this much time on a project, but in the end, it's all come together as something that I'm really proud of. Actually, it's one of the funnest things I think I've done in a long time. That's probably why I dedicated so much time, because it was really fun to just to eventually work out how to do some of this stuff and to get it working was really neat.
It's absolutely fascinating, isn't it?
Yeah, it really is fantastic.
Can you give an estimate on how many hours?
Oh, good Lord.
Do you want to think about this?
I've never counted, but let's look at something slightly different. Maybe if I sign into GitHub. Oh gosh, let me just stop myself sharing all of my passwords. Give me a sec. I will do that. Oh no, I don't want to add a passkey, not yet. Right, let me nip to the GitHub repo, and then we can see how many commits there are. Just to give you an idea. I feel like this is the way. Don't judge my commit messages. So this is some commit that I did the other day. Apparently I'd got the language wrong. I know if I go back one, it'll tell me just how many commits. 3,128 commits for the Visual PDE project. Do you know, some of these are like atomic commits. They'll be really, really tiny. But some of them are not. Some of them, I don't even know if GitHub will be able to crunch all this data to say how much stuff happened. But it's got to be hundreds of hours. It's tens of thousands of lines of code to get it to work. In fact, so to get this, this isn't going to be very insightful at all, is it? I don't really know. That's not been very helpful for me. Apparently, I was very busy in November. But it's been a long project that really is a labor of love, right? Thousands of lines of code is not fun, especially in a language you'd never learned before. So I was new to HTML and JavaScript and, GLSL, which is what the back end of all of this is to make it go. And it was a really mad undertaking to learn all of this stuff on the fly. It was great fun. It was lovely. It's fun for me. I think it probably would have been tedious for lots of people, but it was pretty fun.
Yeah, I think it all came from rendering a cube on a web page. That's
a static cube as well. I couldn't even move it. It was just a 3D render of it. Getting the color to change was a big milestone for me.
Gosh,
it was a bit ridiculous. Something's come of it though, which has been really fun, which was really unexpected. I'm making Henry pull his hair out by sharing screen and not sharing screen now, but I'm going to do it again. Sorry, Henry. My favorite thing that we've started doing is we call them visual stories, but the idea is to take all the intuition that maybe a mathematician or a scientist might gain from using visual PDE, but craft simulations and stories around those simulations that let people who aren't mathematicians engage with science and maths in a way that's actually meaningful. So we called them visual stories. Doesn't really matter what they are. Let me pick one. This one I like, actually. It's quite pretty. So we realized that there are lots of topics. Well, this isn't really a big realization. There are lots of topics that people might be interested in that really are behind lots of science to understand. So this might be climate change, or it might have been dynamics of virus transmission, which people obviously cared about an awful lot a few years ago. And what we wanted to do was bring people closer to the actual research grade models that people were using. In fact, this virus transmission one is a better version of that. So, for instance, here's an article that we've written along with the creators of a particular model that was used to inform the Welsh government, I think, actually during the pandemic. So, a real research grade model. And what we've managed to do working with them is to get that model running in your browser in Visual PDE. And I don't just mean like a Mickey Mouse version of this. I mean the actual model that they were using with different parameters to make it look pretty, but the actual model they were doing. So this is a top-down view of you imagine it as a room. And in the center is a source of virus, some abstracted airborne virus. And when you click, then it's just like somebody coughing, for instance, is the way of in thinking about this. So I'm clicking in a room and you can see that the concentration decays away. The bit in the center isn't, because that's where the person is stood. You can also track if I'd been stood in the room at this position for the whole time, what's the chance that I'd have caught the disease? And you can see all the places that I coughed, for instance, so on. But the point of this model isn't to let people click and go, oh, look, a pretty dot disappears. It's to try and get some understanding for why the science is tricky and complicated. And the problem was to do with, well, what if there's airflow in this room? So this is exactly the same setup as before, but now there's airflow from left to right with a little bit of recirculation. So you might see some things that look a bit funky. And what you can do is, you don't have to be a mathematician to know that if you drag this slider, you're changing what the airflow is in the room. We walk people through it and say, look, this is interacting with, a live running mathematical model, which is basically not something that you could do before, at least not to my knowledge in this context of model. And you can see that, look, if I make it go to the left instead, then I get something that's quite different. That sort of blob that just gets shot to the right is because of recirculation. That's why it looks a bit weird.
Yeah.
But now you get to ask the question, what if the person moves? So imagine you had a waiter in a restaurant going around. So naturally, in this case, you expect everyone that's sat in this ring or on the annulus is going to get infected. You can see this sort of probability building up over time. So then the question is, well, what happens if I turn on the air conditioner? What does the distribution of virus look like? And it's not obvious, right? I can tell from your faces, hopefully, that it's a thinker, right? It's not obvious what you should be doing. So we pose this question, so you build people up to try and hopefully gain some intuition for what's going on, and then just say, look how complicated this is. So this is the same setup, the person rotating, going around the room, but now we've got some airflow.
Oh my goodness.
And to me, this concentration pattern is not obvious, right? I've stared at this tens and tens of times, and I don't know what's going to happen from this. But now this is a way that people can hopefully interact with it and at least gain some sort of intuition. Look, you turn the airflow off and it goes back to exactly what you thought it would be. You can also get it to go the other way, of course. So now my question is, if I jump to what is the probability of having caught the virus? What does it look like now? Any guesses? I'm sure you know the answer.
Bit more everywhere, I would guess.
Everywhere is a great answer. Yeah, exactly. It's just everywhere, right?
Wow.
It's completely covering the whole room, pretty much. And sure, that might be obvious if you spend ages studying these sorts of transport models and have some intuition for this sort of stuff. But there's no reason that anybody else should have that, particularly someone who doesn't, they're not a scientist, they're not a mathematician. So that's what we loved doing with this, was giving people a way to interact with science and maths, even if they don't necessarily resonate with science and maths. Gives people a way to explore without that barrier of an undergrad and then a PhD in order to do stuff. I'm going to stop talking again about this because I'm at risk of monologuing for hours. But here's a cool one we did recently, which is a bit more stupid. 30 or 40 years ago or so, a big container ship lost some rubber ducks off the side. You might have heard of this. It's quite a fun news story as they go. So what we did was thought to caricature this model. We grabbed some ocean flow data from NASA, just simulating advection across the surface, and managed to convince Visual PDE to let you use PNG files with transparency to have the PDE solution on top of the well, not quite on top of the world map. And what you do here is you can click to add ducks basically, and the yellow is the concentration of ducks. And this is a bit of a silly story, but it lets people explore what are really complicated ocean dynamics. But you can see, if I let this huge source go in the Pacific somewhere, that eventually it makes it all the way around the south coast of Argentina and Chile and wraps around and eventually ends up, near the coast of Africa. And of course, you can do this where, well, what if you get to click and choose where the ducks all started and you pick a source? But, it's a bit silly, but it gets people to interact or at least acknowledge how complicated this problem is. And, there's the maybe less cheery side of these are approximately the same sort of physics as if there was an oil spill. Sure, there's more complicated things going on, but you would learn similar qualitative lessons for this. It's just been super fun.
The next given question is, where's the most likely place to find a duck?
Whoa.
Oh, where is the most likely? Well, probably in this terrible model, there's actually a continuous source of ducks from the ship. So I'm going to bet it's there.
Infinite ducks. Nice.
I think there is actually like a trapping region. I don't know if you can see it on stream. There's a vector field plotted on top of this. There's like a little circulating bit here.
Okay.
So I think if any ducks enter that region, I think they get pretty trapped or trapped-ish for this. Yeah, we have there's a customizable version of this because everything in Visual PDE is just written with text. This looks a bit ugly because I've had to try and get months to work, but everything is here as a PDE that you can just go in and edit and explore and see what happens. So if you want to explore if this really is a trapping region, then knock yourself out. It's right there and available to play. Yeah, look, they're all stuck there forever now, I think. Poor ducks. Rubber ducks, I should say. I hope I stressed they were fake ducks and not real ducks. Otherwise,
I think this was mentioned.
Okay.
Gosh, I've got to ask for some advice. So learning new kind of coding language, particularly, is surprisingly difficult. They all have their nuances and everything. Have you got any advice that you've got for that? How it's best to go about it?
So bad. Just trying. Sorry, Henry. I stopped showing my screen again. So I find it really difficult to learn a new language. I've played around with a few now. So I remember when I was a bit younger, playing around with some Python and some C, very bad C, and a little bit of Julia these days, and a little bit of MATLAB, but a tiny bit of R, and just dabbling in things. Which didn't really work. It was fine. I learned some stuff, but I never sat down and just tried to learn something. The best thing for me was having a project to do. So if I started a new project and I say, okay, I want to learn Julia, cool language, by the way, if you've not encountered it. If I want to learn Julia, I'm going to solve this problem that I have using Julia. And it will take me longer than the bit of MATLAB that I just know by heart that I could write down. But it seems like a really worthwhile thing to do. So some other advice, which I never expected myself to give. So I'm a bit skeptical about generative AI in general, maybe unhealthily so. But as being in the education sector, we can get free GitHub Copilot, which has been amazing for me to learn a bit more Julia and to do a bit of JavaScript for Visual PDE, because there are lots of nuances that, if you know what you want to do, but you don't know the syntax, it's been really helpful for that. I mean, it gets lots of things wrong lots of the time. Don't get me wrong, it's not perfect, but it was actually really helpful for me. It definitely accelerated my learning process for this. Sometimes it was doing really stupid things, but that's okay. It was good to learn that they were stupid things to do.
This is true.
Yeah, but I also love learning new languages and just messing around with stuff. So that the approach of just try it and unbreak it works for me. Yeah, really might not work for everyone.
Of course. Yeah.
I never recommend learning JavaScript though. Sorry, carry on.
Okay. Yeah, I was just going to say that
JavaScript.
I have heard of your Visual PDE thing. I've been aware of it and I've seen some stuff, but I never really appreciated how powerful of a tool it can be with regards to say these stories things. I hadn't really fully appreciated that sort of that sort of application for it. I just think it's fantastic.
Thank you very much. It was unexpected. All of this project was unexpected, and that's what makes it great for me and a really fun thing to have done. It was, a research activity that wasn't really a research activity to begin with, that's sort of blossoming and taking up a huge chunk of my time, and that's been really exciting. It's been really, really good, and it's so nice to see, people using it. It's just remarkable, to have made a thing that people are using is just really fantastic. I'm sure more people have gone on Visual PDE than will ever read all of my papers combined for the just ever. So it's really nice to have a project that someone has used.
Mm-hmm. Yeah. So if you had like access to it during, say, like your undergrad, like how would you have like used it?
Well, I think I'd be a much better mathematician if I'd have used it myself, because I had really poor intuition for loads of PDEs. It was something I really struggled with. Whereas now I know, if I knew about Visual PDE, we have loads of sort of the basic or standard PDEs that you might encounter. So the wave equation and the heat equation and advection equations and things. We can now even do some elliptic equations too, like Laplace. And it would have really, really helped me to just play around with it. There's no replacement for a good lecturer and lecture notes and actual teaching. But this as an aid to, if someone introduces a PDE, to then be able to get some intuition for it. So even the heat equation and changing the boundary conditions, like what does that actually do? So if you have a heat equation in a 2D box and you put Neumann boundary conditions on it, the heat's not going to escape. And you can take that on faith. You can do the analysis, which is, do an integral and see what happens. And you can just simulate it and see what happens on Visual PDE and say, well, what happens if I change it to a Dirichlet boundary condition? What changes? And I think that would really help me, because I missed out on that intuition, and I've only got it, since during my PhD, for instance. And it would be really nice just to mess around with stuff. There's no, but the point was to reduce the barrier to entry, and I think we've sort of done that, or I hope we've done that anyway with all the examples and things.
Yeah, I definitely feel like you have, for sure. Yeah,
I hope so. And if anyone has complaints about it, also let me know, because it would be lovely to make it better. It really is still a labor of love. So if something doesn't work for someone, we'd love to make it better.
Nice.
Yeah. No, it's really fascinating, isn't it? Really fascinating.
Oh, yeah.
Thanks for indulging me to talk about it for quite
so
long as well. I did warn you I wouldn't shut up about it. So,
no, it's actually absolutely a project worth showing off and letting everyone know about it. Absolutely.
It's really fun.
Nice. I mean, do you think this comes to a nice sort of wrap up, I suppose? Yeah, I mean, it's been fantastic talking to you.
Well, thanks so much for having me. It's been really lovely it's just been really lovely to chat. What a nice way to end the week.
Yeah, I know, a nice Friday afternoon activity to sit down and chat. It's good. It's nice, good.
Relaxing. It's good.
Yeah, thanks for the invitation. Yes. Lovely to join you.
Of course. It's been a pleasure. All right, so we shall go on a short break. And then we will catch you in a few minutes to have a final wrap up, so don't go anywhere. But yeah, it's been lovely talking to you, Ben.
Thank you very much.
Thank you.
Pleasure. Lovely to chat to you too.
Okay.